All right, well, good afternoon, everyone. My name is Stanislave Borisova, and I work at RISE as a sustainability researcher. Today, we will be talking about data centers and LCA, and I decided to split this section into three parts. In the first one, I will give you a general overview of what LCA is, how it is standardized, and what the main steps are. Then I will walk you through a small demo. And finally, we will have a look at some preliminary results of my model of Boden type data center. So let's start. What is LCA? As you probably know, LCA stands for Life Cycle Assessment. It is a method that enables us to compare products or goods in their overall environmental impact. And it is standardized in ISO 14040 and 14044. Although it is mostly becoming popular and kind of famous now, it's been used for decades. And one of the first somewhat renowned cases of using LCA was in 1960s when Coca-Cola engineers decided it would be good to understand their environmental impact beyond the recyclability of the glass bottle. Here you can see that LCA takes into account the whole life cycle of a product and all of the stages relevant to it, from the raw material extraction through use and maintenance all the way until disposal. And then it translates these stages into various sorts of environmental impact. Probably the most discussed one nowadays is global warming, but of course there are other sources of environmental impact too. For instance, eutrophication, which maybe you don't know. It's basically the accumulation of phosphorus in water, which leads to overgrowth of algae, which then suffocates the life living in waters. But other sources of impact too, such as human toxicity, ozone layer depletion, and so on. Why do an LCA? LCA has two purposes. The first one is to compare two equivalent solutions. So for instance, we could be examining how to operate a data center and then look at different alternatives. For instance, doing this by Facebook data center, or for instance, by the Boden type data center. And the result of such a study would show us which alternative is more environmentally friendly. Now, as you can imagine, I do not have access to the bill of materials of Facebook data center, which is why today we will spend this time looking into the other purpose of doing an LCA, and that is to identify hotspots. This means that we look at all the processes involved and we trace the impact in specific materials or energy uses within these processes. And the reason for that is that so we can improve the environmental impact. On this slide, you can see the framework for LCA, which then shows you, I hope you can see my cursor, the four main steps, which are goal and scope definition, inventory analysis, impact assessment, and interpretation. And to make this more concrete, I can give you some examples based on today's case. So we define our goal and scope as the data center operation of the Boden type data center for 30 years. This is based on the assumed lifetime of the building to be 30 years, and we assume that the servers used there will be run for 3 years, therefore we will have 10 refreshes. At the moment, the part of scope are not cooling, racks, and power distribution, since the model is not finalized yet. Later, we move on to the inventory analysis, which means we calculate the flows, we set our assumptions, for instance, on where these resources are shipped from, etc. And then we go to impact assessment, which means that we match the flows of materials and energy with their relevant environmental impact. This gives us results, which we can then interpret and see what this means for our particular case. All right, and so now I would like to walk you through a small demo. as I was trying to not try my luck, I have made screenshots, which I will walk you through. So as you can imagine, life cycle assessment is mostly based on databases. One of the most common used databases is EcoInvent. It's a Swiss-based database. And as you can see, it contains lots of different flows of materials, energy, transport, processing, used, waste. And just here on this particular slide, we can see all different types of aluminum contained in EcoInvent. So what you can notice is that there are different types of aluminum production here, and also different origin. Here, this one, the RER stands for rest of Europe. Then we have rest of world, we have China, etc. So let's say that you're building your model. What you would do is you examine these background processes, and you then select one that suits best what you are trying to model. Okay, let's assume we have chosen one flow. And then what you can observe here is that it contains inputs from nature, such as water. Then we have inputs of materials and fuels. Later, inputs of electricity and heat. And finally, we go to outputs. And sources of outputs here are usually emissions, classified into different parts of the environment. So emissions to air, emissions to water, to soil, which are not specified in this example, and so on, up until the point where we get to waste treatment, for when this particular flow is not being used anymore. So based on these background processes, we go and we build our model on top of them by using so-called foreground processes. As you can see here, this is our specific example of the data center and the processes that I have modeled to create the data center shell and also the servers. To give you a better overview, we look more in depth now into mainboard, and we see that to produce one mainboard, we have all different types of metals coming in, and then we have two sorts of transport, because we assume that these parts are transported by plane from China to Poland, and then they are assembled in Poland, and they are shipped from, let's say, the airport to the manufacturing site. Another sort of foreground process is the data center operation, where we assume that the output of it is the service of data center for 30 years, which we mentioned earlier. The sub or byproduct of this is waste heat, which in our case at RISE, we suppose this actually has value because we're researching multiple industrial symbioses, which we can base on this waste heat. And of course, the input is the electricity. At RISE, we have sampled our air coming from the data centers, and we sent it to an independent lab. So we have a rather extensive knowledge of the emissions to air caused by our data center operations. All right. And now that we have modeled our these foreground processes, we also look at the waste scenarios, because as I mentioned, LCA covers the entire life cycle of a product. Waste scenarios basically specify how a certain part will be dealt with afterwards. So for instance, whether a particular part of a server will be recycled or not. And to bring you closer to that, we go back to the mainboard, but this time to mainboard waste scenario. And we see that of this mainboard, 2% is aluminum, which will be recycled, 56% is scrap copper, which will go to secondary market, and so on. Everything else that will not be recycled then ends up in the municipal solid waste, in this case in incineration. With this, we have modeled our processes, and we can move to the next level, which is the product stages. So we build different product stages and then we will be able to run our computation. So here you see assemblies and two sub-assemblies, with two main ones being the server assembly and the building assembly. What does an assembly contain? So you can see here that the server assembly contains all small sub-assemblies of all the parts that go into a server. This means that after we have modeled all the processes, we put them together, and the result of this assembly is having one server. We basically do the same with the building, and then we put them together, we combine them, and we come with an assembly called data center ready for operation, which basically is the shell with the servers that were transported to the place of the building. And then we move to the next product stage. This product stage is the lifecycle product stage, where we take what we just modeled, the data center ready for operation. We connect it with the operation process, and that you have already seen, it is the process with the electricity input, the service and heat processes, output, and then the air emissions. And another, maybe last product stage would be the disassembly. As is probably not surprising, we see here, for instance, the server, and of course it comes to disassembly and breaks down into the sub-assemblies which we had modeled earlier. But what happens here is that we connect these sub-assemblies with the waste scenarios that I had showed you with the main board. So this basically means that for the known waste scenarios, these parts will be treated by them, 100% of these parts, or some of the parts will not be recycled at all. Therefore, they are not separated or used in these disposal. Instead, they will go to the waste scenario and be incinerated. All right. And with this, we have finished our model. And now we can set up the impact assessment so that we get our results. So here we take in the final product, the data center operations, and we specify the method how we want to have it examined. There are various impact assessment methods. They basically differ per region and the school of thought, either on the grouping of impacts or on how impactful certain substances are. For instance, whether the kilogram of methane is equal to 32 kilograms of CO2, or whether it is more or less, and similar. All right, and now we're calculating the impact. And the first output that we see after finalizing the calculation is this type of a table, which then shows you different impact categories, from climate change to all different ones. And what I would like to point out is that, as you can see, all different impact categories have different units. So this means that it is impossible to express things such as freshwater ecotoxicity or human toxicity, eutrophication, in terms of CO2 equivalents. So whenever we're talking about CO2 equivalents, we are just talking about the climate change impact and not the rest. Here you see the total impact per category, and then as we go more to the right, you see the column C, which basically we can interpret as the embodied impact, and this column, which would be then the operation, so the electricity for the data center. Okay, and now I'm going to show you the chart. This chart actually contains the exact same figures as we've just seen before, but I suppose it's a little bit easier to follow and a little bit more visual. Unfortunately, the chart that I got from the software had very small legends, so I decided to zoom in a bit. The very surprising thing is, for instance, the climate change result, where we see that only 2.4% of the climate change impact comes from the embodied part of the data center. But here I would like to ask you not to take this out of context, because, as I said, the model is not finished yet, and I'm not sure whether these are the final numbers or not. nonetheless, this is what the results would look like. So you see also that it's the embodied part of the data center that's very much responsible for the depletion of minerals, fossils, and renewable resources, and so on. All right, but what we can do also is then to take a closer look and try to figure out where does this impact come from? Because so far we only know there's impact from the data center itself and impact from the operation side of it. So we create something called network. And here in this network, you can see all the processes linked to each other so that in the end, we can provide this data center operations service. And we have a legend for different types of processes, such as material process in this bright green. Here we have transport, energy, sub-assemblies in blue. This is use in gray, and finally the life cycle. We then zoom in a little bit. What this shows you is that there are other processes behind the main ones shown in previous slide, but what is shown literally depends on the magnitude of impact. So if you go deeper, there are smaller and smaller sub-processes behind. And now we decide to trace the sources of impact. So in the data center operation, all of the impact comes from the electricity. But where in electricity does this impact come from? So we examine this particular process and we see that the vast majority actually comes from the voltage transformation, then to a certain extent from the distribution network, and finally the third largest impact would be the grid, the market of electricity in Sweden. We can do the same thing with other processes. So we then look into the counterpart, the data center itself, and we see that, maybe not so surprisingly for some, the vast majority of impact in the data center comes from the servers. And it's by 2 orders of magnitude larger than the building itself. And similarly, the transport to deliver these servers to the data center is much more impactful than the building. Then we can zoom in closer and look at what in the server has impact. Oh, I forgot to mention an important thing, which is that all of this impact we're looking into right now is just climate change impact. It is possible to examine the same way of impact per other impact categories, but right now we're looking at CO2 equivalent. So now that we go to server, we see that the main sources here are chassis, HDD, packaging, PSU. And then if you go even further, what you find out is that the main materials that cause impact are steel, aluminum, gold, copper, transport, polycarbonate, and in the case of packaging, it is largely extruded polystyrene. And then we go on to the other side, and we touch the data center building. And what we notice here is that the main sources come from the walls, flooring, structure, and foundation. And if you go one step further, you discover that in terms of walls and foundation, the environmentally polluting flow would be concrete. When it comes to flooring, we're talking about glued laminated timber. And when we're talking about structure, the impact comes from steel. Right. And what can we do with all of this? So we've identified what causes most impact in terms of material, transport, and energy. And then the next step where we can bring this forward would be to see, okay, if the impact comes from the materials, can we substitute these materials? Is it viable to find other materials that will fulfill the same function? If it's from transport, then we can try whether we can ship parts from a supplier that is closer to us. If it is energy, we can then ask ourselves whether we can operate more efficiently, and of course, try to use renewable sources of energy. And finally, I think it's also important to mention that we can report the results along with the assumptions, so not taken out of the context, so that we as the industry can understand the environmental performance of different data centers, of different servers. So we get the feeling for what is environmentally friendly, what is not, what is good, what is bad, what is a high impact and what is low. And similarly, so that we understand how much of the remaining CO2 budget we're using. All right, and with this, I would like to thank you very much for your attention. And if there are any questions, I will do my best to answer them. Thank you.